And we are live. So, there we go. Good. So 8.1, we're starting matrices. We're good. You guys remember systems of equations?
Yeah.
Okay. What are the systems you speak of? We used to use elimination, substitution, that whole bit. Did I ever teach you guys how to do with matrices?
Kind of went and started
Like the little graph box and you like.
So we're gonna do now.
I remember that from Mr. Ross.
All right, so this is the unit where we actually do it with matrices. There's gonna be a couple of different ways. I guarantee you. Well, I'll show you by hand. There's also ways to do the work with your calculator. So the calculator will do like the monotonous stuff. Ooh, that's awesome work. All right, so let's do this. Let's get started with the first objective, the augmented matrix. Now, that sounds fancy. It's not. It's not fancy at all. Then we'll do some row operations, which is really nice because there's only really 3 row operations you can perform. And then we'll do some Gaussian elimination and some Gauss-Jordan elimination. So, first let's talk some vocab. Matrices, this is a matrix. And the dimensions are 2 by 2. It's rows by columns. Always rows, yeah. You saw it last year, so you should be. Okay. Awesome.
He's just like,
You know what? Sometimes I throw things in and I don't know if I've covered it or not, but if you remember, then that's super duper dude. Now you gotta.
yeah, you kind of talked about matrices before.
Alright, cool.
Oh, I remember.
So we talked about them, right? The items inside of the matrix are called elements. And each element also has its own address, if you will. So if I talked about R1C2, which element am I talking about?
Row 1, column.
Row 1, column 2. R1C2 is row 1, column 2. So the element I'm talking about is 2. That is row 1, column 2. What is the address, if you will, to 4?
Row 2, column 2.
R2C2.
Oh, yeah.
Darn, we don't have a large enough matrix to go with well, there isn't any. It would only be ours, rows and columns. All right, anyways, let's move on. You guys are good with that vocab?
Yeah.
I can wait. I just have some of this Java. That too? After I have plenty of Java? You ever have enough so much coffee, you're like, it feels like Drano for your body. Yeah, the darker? Oh my god. Moving on? Let's have that conversation right now, right?
Are we studying online?
I love coffee. What?
Are we live?
Yeah. It says live.
Hey.
Stream health is orange.
Honestly, I feel like coffee doesn't.
Okay. So the augmented matrix, it has a vertical bar that simply separates the, what do they call it? The 2 groups. And when I say the groups, we're talking about the left side of the equations versus the right side of the equations. Okay? And I'll show you what one looks like. Voila! See the system over here?
Oh, I remember those.
This is the augmented matrix. So
You
it's,
told us about this.
I like that.
we did this.
let's hope we did it.
Yeah, you kind of started doing it with us.
Yay!
I remember this one also.
Alright. So
Is this the lesson?
I didn't like matrices.
Oh, yeah.
Oh, I already learned this. This is easy.
It's easy. It's so easy.
good.
Especially plugging the one thing and plugging
Because I love
Yeah.
this. This is my favorite
Can you go
lesson.
through
I keep hearing a lot of I love. I hope you feel the same way after we're done. So let's continue.
Keep the same energy.
Keep that energy, right? So notice how we have a system of equations up top. This is the augmented matrix. What we're going to do is we're going to work our way through the system, and we're going to try to get something that looks like this at the bottom, the lower right-hand corner. Notice that there's a diagonal of 1s, and there's zeros below that. This form that you're looking at is called row echelon. It's called row echelon. Row echelon.
Is that how you pronounce that?
I don't know. It's called row echelon. And you want to have all those. You want that diagonal of 1s. Everything under that has to be a 0. Anything above, we don't really care too much. And I'll show you why that's important. Okay? Can we move on?
No.
Nope.
Well, how did you do that?
That's what I'm going to teach you. Right now. Right now, right now. Idiot. Next. No PDA, please. Alright, so we're good with this slide?
No, hold on.
Not yet?
Not yet. When there's like a diagonal row of ones and then there's zeros. Yeah, like that one. Stop, you got it stuck in my head the other day.
Sorry. And it's only this class. And it's only this class.
Maybe it's because
I whistled this, that song in this class. I don't whistle in any other class. Every single day. I don't even know why. It's a song from War. War is a group from like what, the 80s, 90s?
It's like maybe like I think it's late 80s. I think.
Yeah, something like that.
Okay, you're good.
Alright, moving on up. Next slide. Oh, there we go. So, after we perform row operations, we're trying to get this diagonal of ones, and that's called row echelon form. Okay? I just said that. Pretty much. Exactly. Now there's another form. You see the diagonal of ones? Where there'll be zeros below and zeros above. That is called reduced row echelon form. Reduced row echelon form. So if you have 1, 1, 1, 0, 0, 0, 0, 0, 0, something that looks like this, we'll call this X, Y, Z. This is called reduced row echelon form. Reduced row echelon form. And that is the most best. We love that one. That's just much more work.
It's just a lot easier.
A lot more worky.
Is it?
Yeah. Someone give her a hug, please.
Eli.
Step up, man.
He just.
Aww. Okay. Can I change the slide?
Yeah.
I can hold on. That's not at all though. There's no heart in there?
It's like so sad.
It's empty.
Jeez, Lily.
There literally was an echo.
The main diagonal being one,
Has to be ones.
all ones.
All ones. Okay?
And that's this bottom one. Is
Lily, are you okay?
Yeah, this bottom one is called reduced row echelon form.
Actually, Paul.
We're good? Okie dokie, artichoke. Now,
Lily.
all of this is just a lot of jargon for telling you that there are 3 row operations that you can perform. The first being, you can row swap. That means I can literally take one whole row, and trade positions with another row.
Oh, it's a Rubik's Cube.
It's called, yes. It's a Rubik's Cube. So, first operation is row swap. You can take the first equation, throw it to the bottom, and take the bottom and throw it to the top. You can swap any rows you want. Sounds good?
Yeah.
Okay. Good?
Yeah.
Alright. Second thing you can do is you can multiply any row by some value.
What do we call that?
Oh, by a non-zero number.
Multiply. Yeah, you don't want to multiply by 0. That's bad, right? You can already think of the consequence of multiplying by 0. So, you can multiply a row.
I'm pretty sure somebody just died.
Can you divide a row?
No.
No. How do we get around that?
You multiply by half. Like a
Multiply by a fraction. Exactly. Pew, pew. Okay. Now this last one is probably the most confusing. So please listen to this last one. I can multiply a row by some number, and I can take those values and add them to a different row. So let me explain that one more time.
Is
So
that
let's
3?
say
Is that 3 or 2?
that's the third rule. So let's say I had, I don't know, 1, 2, 3, 4, 5, 6, 7, 8. Now this is just really generic, okay?
Oh.
Now, let me show you the difference between the two. Here, I don't like that. I can, like here I can say, oh, I'm gonna take row 2 and I'm gonna multiply it by, I don't know, 2. Okay? Here's what's gonna happen. Row 1 does not change. What changes? Row 2. That would become 10, 12, 14, and 16. Does the last row change?
No.
No, it doesn't. Make sense?
Yeah.
That is the literal notation. I'm multiplying 2 by the second row. I'm multiplying 2 by the second row. Okay?
Wait.
Go ahead. Process that. That is the second rule. I'm demonstrating for you the second rule.
Oh,
Yeah, so I'm taking the row 2 and I'm multiplying it by 2. So the entire row 2 got twice as big. The 5, 6, 7 became 10, 12, 14. The 8 becomes 16.
okay, so the one that you heard, like adding the
Okay, this is an example of rule 2. Okay? Now let me show you rule 3. You really want to listen, because if you don't know the notation and you mess up these rules, you fools. You're wrong. You just lost points. Okay? Here's the next rule. I can take row 1 multiplied by 3, and I can add those values to row 3. That's my notation. So let me show you what that looks like. So please watch. So here's my matrix. Is row 1 changing?
Yeah.
No.
No.
What's changing is row 3. So I'm going to leave
Oh.
1, 2, 3 by itself. Is row 2 changing? No, it stays by itself. 12, 14, 16. Row 3 is changing. So here's what I'm going to do. I'm going to take the values from row 1, multiply them by 3, and then add them to the third row. So that means that the new values, let me use another color here. I'll use the green. So what's 3 times 1? 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Let's add these up. So my next row is now 12, 16, 20, and 24. Double check my work.
Yeah.
That's rule 3.
Oh, okay.
That's rule 3.
They're like operations pretty much.
I'm gonna
Yes, they're called row operations.
Oh.
That's exactly what they're called. Okay?
Yeah. This is an example.
Anybody want to see rule 1 in as an example?
I don't know. I think it kind of makes sense.
You know what? I'll do it just so no one's like, you never explained rule number 1.
Yeah. Sure.
So, here's the way rule 1 looks like. I'm swapping row 1 with row 2. I'm swapping row 1 with row 2. So my new matrix will look like this. 10, 12, 14, 16, 1, 2, 3, 4, 12, 16, 20, 24. So all I did was swap row 1 and row 2.
Can you apply the 3R1 plus R3?
That was on this step.
Yeah.
So this produces this matrix. So you're always kind of going back, right? Or forward, I should say. So this operation produced this operation produced this. I don't like that. This row produced that.
Jeez.
I don't like it when it does that. Blech.
I like how the first row just never got messed with, which is all the other ones.
Okay. What are you talking about? I swapped it. It's right here,
Yeah,
see?
but like it's numbers. Can you go to the top row?
Go up here. Uh-huh. Now, if you are visual, you can already imagine these being the equations of a system. I'm really just reordering the equations. Put one on top, put one in the middle. You can do that, okay? Multiplying a row is equivalent to trying to do, remember elimination? Like if you had a 2x with an x,
Yeah.
in order to eliminate, what did you have to do to the bottom equation? You had to multiply the whole thing by 2, right? And we're not really violating any rules because rules of algebra say whatever you do to one item, you got to do it to everything in that equation. So that's what we're doing here. That's all we're really doing. But those are your 3 operations.
Okay.
That's all you can do. You gotta live within those.
Now it's gonna get hard.
Yes. Okay, because why do we need these rules? Well, we want to take a matrix and we want to, using these row operations, is to put it into row echelon form. We want to put it in row echelon form. Right, with that diagonal of ones and zeros under that. You guys ready to do that?
So with the diagonal, is there only like, how would it go? Would it be where, on the last one, would it be where the 10 is, the 2 is, and the 20?
Well, technically that would have to have 10, 2, and 20 be ones, and then these three would be zeros.
It can't go anywhere else, like it can't.
Has to be that way. That is row echelon. And I'll tell you why in a minute, okay? So can I change it? No. No?
I'm finishing
How dare you? How dare you? What was that? Doritos commercial. You ever see that one? Is that where it's from?
No, I just said that out of nowhere.
There was a Dorito commercial for Super Bowl a few years ago, and the guy comes in and he's like, he's got Doritos all over his belt and his hands and his shirt's all orange and stuff. And they're like, hey, people have been complaining that their Doritos have gone missing. And he looks at it like, because I love Doritos, it's me. Like, how dare you? And he gets up and like, shh, Doritos are falling everywhere.
The one is the one where the guy's in the office, he's like, you Doritos, like, oh, can I have some? The guy's like, oh, no, they're not. He forgot to leave us for it. He like grabs the guy's hand and like starts licking his hand.
No, that's bad. Hey, what happened? What did I do? Oh, here's a notation for you one more time. I'm just going to move on. Here we go. So, hip, hip, hooray. Okay, so visualize in your mind, you're trying to get this diagonal of ones and everything under it a zero, right?
Yeah.
Now, as you look at these, I think the first obvious thing would be to take row 1 and to swap it with row 2, right?
Yeah.
You guys see why? Yeah, row 2 already has a 1. So that means I've got a 1, 6, negative 3. What? That's Kirby. 7, 4, 12, negative 28. You guys have to help me out here, because sometimes with so many numbers, I lose it. Okay? All right, cool. So I've got my 1. Yay, I got my first step. What the what? Okay. Let me give you a technique, because I don't want this to be like, oh my God, what do I do? You always want, you always are going to do this. You're going to start with a 1, upper left-hand corner, and then you're going to want to make zeros of everything under that. Make sense?
Yeah.
Then you're going to go to, no? I'm going to show you right now. But I'm giving you a technique. Start by making this a 1, and then make zeros under those. Then we're going to go here. We're going to make that a 1. Then we'll make zeros here, and then I'll go back and make this a 1, which kind of is right now already. That might change though. But that will make me my diagonal, and then zeros under that. Okay? That is always the method. Start at the upper left-hand corner, make zeros under that, then go to the middle, make it a 1, zeros under that, and then finally go back and get your last 1, okay? All right. Okay. What's up?
Okay, so the diagonal only goes from left to right. It can't go right to left.
No, it has to go like this. And I'll tell you why at the end. Are we good?
And what if there's not a 1?
Then you make it a 1. Do you guys want me to skip this step? You want me to switch the row up and show you how to make it a 1 right away?
No.
No? It won't be bad.
No, I know they want it.
You know what? Okay, let's move on. You guys ready?
Yeah.
All right, next thing I need is this 4 to become a 0. I'm going to take row 2. Sorry, just kidding. I'm going to take row 1. I'm going to multiply it by negative 4. And I'm going to add those values to row 2. This is why. What do I need to add to 4 to make it a 0? And since this is a 1, 1 times negative 4 will give me that negative 4 I'm looking for, doesn't it? Okay? So, let me put these side by side. Is my first row changing?
No.
1, 6, -3, 7. Now, my middle row is changing, so let's see how it's going to change. Here's the values. -4 times 1 is a -4. Then I've got -24. Then I've got 12. And finally, -28, is it? Someone double check my work?
Yep.
Yeah? Okay, cool. So let's add them up. -4 plus 4, 0. 12 minus 24, -12. -20 plus 12 is a -8. 8 minus 28 is a -20. Did my last row change?
No.
Nope. -3, -2, 1, -9.
Oh, I see a thing.
Okay?
And if
Wait, so then now right now, like, so would you do like now? So like the next one would it be 3 R1 plus R3?
It'll be 3
R1
R1.
plus R3.
Yes. Yes. That's the next logical step. I'm going to take the values in row 1, multiply them by 3, and then add those values to the third row. I'll let you guys process that.
what? Do you understand why?
Right?
Because you're multiplying row 1 and then you're adding it to row 2, so that we get rid of that.
Oh.
Yeah, we're not subtracting them. Yeah, and then so we're doing the same thing down here, but for this number, for the -3. So yeah, we'll get 3, 18, -9, 21. And so then,
Yeah, that's now it's this is up.
What's up? No.
we're gonna have to end up changing that one no matter what.
It might, yeah. But we worry about that at the end.
Yeah.
So, question. Is row 1 changing?
No.
No. 1, 6, -3. Is row 2 changing?
No.
0, -12, -8, -20. Is row 3 changing?
Yes.
Yeah, I have to add the third row with those green numbers, don't I? So what's -3 plus 3? 0. -2 plus 18 is? It used to be 20. They changed it. -8, correct?
Yeah.
And then... No, wait, man.
11. What the? Sorry. I'm so bad today.
That's okay. I'm a bad arithmetician, too. Like, I'm a good mathematician, but man, you throw some times and pluses at me. Whew. Where's my... I don't have enough fingers.
Wait, times and pluses?
I know, I was trying to be sarcastic. Alright, you guys okay with my matrix here? Oh, look at that! 1, 0, 0. We're halfway there. Okay? Next thing I need to do. This guy needs to become a... Do I care about the 6 up there? No, because I want that diagonal of 1s, right? And here's the trick. I can only multiply,
Or 112.
but I can use fractions to multiply. So I'm going to take row 2, and I'm going to multiply it by a negative 1/12. I'm going to multiply it by a negative 1/12. Watch what happens. It's not. Does row 1 change? No. So I got 1, 6, -3, 7. What's 0 times negative 1/12?
0.
Yay, beautiful. Now, negative 1/12 times 12 times negative 1/12? That's a 1. Now, -8 times negative 1/12? I might have to do that over here somewhere. That becomes what? 2/3?
Yeah.
So I've got 2/3 in this slot now. And then negative 20 times 12 is going to be what?
It's 1 and 2/3.
5/3.
5/3?
Yeah.
Positive?
Yeah.
Okay, so here's 5/3. Does the last row change? So I've got 0, 16, -8, 12.
So now we would focus on that 16.
Yeah, so now we want that 16 to become a
0.
0.
So
So here's where you got to be careful. I'm going to take row 2, multiply them by negative 16, and then add those values to row 3. And this is the idea behind that. Even if I multiply 0 by negative 16, what am I going to get? And if I add 0 to 0, still 0, so I don't undo my work. But that's why you have to follow that process, okay? So let's see how. Let's see how. I got 1, 6, negative 3, 7, 0, 1, 2/3, 5/3. This is going to be 0. So it's going to be 0. Yes! It hurts.
Oh, Lily. Why'd you laugh? It was just
0, negative 16. 2/3 times 16. 2 times 16 is 32.
yeah.
32/3. That's gross. 32/3. I feel like we messed something up, but we're going to keep going. We shall persevere. And then finally we've got, what is it?
11.
Negative 16 times 12 is... Oh no, we got to go this times this, don't we? Which is...
Wait, I thought it was 11. Was it 11?
Where'd you get 32/3?
Remember, we're multiplying the second row by 16, right?
Yeah.
Oh, I got you.
Ooh, that's not very nice. What's it going to be? 5 times 16 over 3?
Oh, never mind.
What is it?
80/3.
It's negative 80/3? Blech. Alright, let's add them up. 0 plus 0 is 0. 16 minus 16 is also 0.
Blech. What?
What is it this one now?
Yeah, so that'd be 24
So negative
over 3.
8
That's 24 over 3.
plus 32/3. How much is it?
24 over 3. Because
24 over 3 is 8.
Yeah, but I don't know what it is.
So we got 8, right?
No.
No.
Oh, this is 24/3. Oh.
Yeah, I was trying to make it easier.
Alright, so negative
24 over 3.
24/3. That will give us 6 and 2. That's 8/3. 8/3. And then finally, what's the other one?
Big. 36/3.
36/3?
No, that's not the answer.
Oh, you're using calculator. That's
Negative 44/3.
negative 44/3.
I think. Somebody please check.
Hold on, I'm checking. Wow. Sorry, I'm just not. Yeah, it's 44 thirds. Negative 44 thirds.
Looks right. Looks right. Because if you round that to 40, right? Okay. I'm going to move on. What do I need? What's the last thing I need? I need this to be a 1 right here. So I'm going to take row 3 and I'm going to multiply it by its reciprocal, which is 3/8. So, does row 1 change? No. Does row 2 change? No. Now row 3 does change, right? So 0 times that is 0. 0 times that is 0. This time its reciprocal is 1. And in this case, negative 44/3 times 3/8, the 3's will cancel, right? And you're going to get negative 22/4, which is negative 11/2. Negative 11/2.
That is ridiculous.
Okay?
So unnecessary.
Yeah, it is a negative.
So unnecessary.
We'll get to the punchline.
Oh, did you give us solutions or something?
Yes! Thanks for stealing my thunder.
Oh, wait. Oh, my God. I was saying about 1 or y equals that.
So here's what we're saying. You remember we got rid of all the variables, all the letters? This is the x column, y column, z column. This is saying that 1z is equal to negative 11/12.
Yeah.
So I've got 1. Yay! Now what I can do is I can take this solution, plug it into the second equation, which says y plus 2/3 z is equal to 5/3.
And then you plug that in.
And then I plug in z, and then I get y from that. Now that I have x and y, I go to the next equation.
What the what?
What the? Did you see that?
Yeah.
Then once I got y, I would go to the upper one, plug in z and y, and then I would get x. That, my friends, is called Gaussian elimination.
And that, my friend, is called.
Bullshit. That's cool. That's
Please watch your words.
Sorry.
No, because, well, remember how we took this and we plugged it into here? Once you get y, let's say y equals, I don't know, 12 for some reason. I have z and I have y, so now I have a new equation up here which says x plus 6y minus 3z is equal to 7. I would plug in z and I would plug in y, and that would give me x. Make sense? Okay, now,
This was like the most intense matrix.
now the problem here is not the thinking, because that's not hard. It's having to go through those tedious processes, right? So, this is why you want to have a TI-84.
Can you go slow so I can write down my stuff?
I didn't want to write down if you want to write down the steps, but I don't write down the steps.
Are we on time? Oh, we got plenty of time, huh?
Yeah.
Yeah. Yeah, boy.
Alright,
Okay.
let's continue.
Actually, let me go back real quick here first. Silencio por flavor. What we've done is we've put this matrix into row echelon, right?
Yeah.
We would have to keep going
Get reduced.
if we wanted to reduce row echelon.
Right.
Now, let me tell you, yes. Now, if you want to struggle through and push through, it would be great because, let me go ahead and do a new page here. If I ended up, once I put that into reduced row echelon form, let's say this was my matrix at the end of reduced row echelon. You really want to look. Once I've gone through all the operations and I've got my zeros above, this is telling me that x equals 1, y equals 2, and z equals 3.
That's why.
So reduced row echelon is much better.
How do we do that?
Same idea, right? So we were doing this, remember? But with the zeros. Then we would have to go after this 6 and make it a 0. Then I would have to go and make these zeros as well.
Well, how do we, what I don't understand is everything you did, like, worked, but what if you multiply by something and it messes up, like, the zero? What?
If you follow that method, it's not going to. Because remember, we always ended up adding 0 to something which doesn't change it. And if I needed a 0, I would multiply by 0. So it didn't undo my work.
But is it possible for it to change it?
Oh, and we didn't.
Yes, you can. That's why you have to be careful with how you're doing it. So let me see if I have that slide here.
6, 0.
I don't. Give me a second. I left out a slide. Oh, this is not your class. That's why. Oh, there isn't a slide for that. So just be careful that you're getting those how you're manipulating that, okay? Alright. Let's go back to him because I want to save you the tediousness. Okay? Right above x to the negative first power, the second feature is called matrix. So go second matrix.
Oh, I remember this now.
Okay?
Yeah.
And let's see here. Which one did we do? I'm looking for the matrix we did. Did it originally start with 412, negative 28?
Yes.
That's the one? Yeah?
Oh, I was
Yes, it was. All right, so I want to go over to edit. And I'm going to edit the first one. Right now I have a 2x3 in there. I don't want it to be a 2x3. I want it to be a 3x4. 3 rows with 4 columns. Because I want make sure I put my x's and my solutions. Now this is not going to write it in the matrix augmented form with that line in there, but it works the same way. The line is there for us. Okay? So I'm just going to type in all the values, which is 4, 12, negative 20. It didn't like it. Let's go to. It wants this negative right here. Not the subtraction. It wants the negative. And then 8. And then we've got, what is it? 1, 6, negative 3. Where's my negative? Negative 3, 7, negative 3, negative 2, 1, and negative 9. Okay?
So hold on before you push it.
Trying to do reduced row echelon on paper.
I am so tired. Oh my gosh. You may continue, sir.
All right, cool. Okay, we're good? No, we're not.
I'm very fast.
All right? I'm going to quit because I want to be on the home screen. Okay? Now let me show you this real quick. Pay attention, man, or you're going to hurt. Second matrix. If I want to look at my matrix, all I have to do is push enter on the names for A, and I'm going to push enter. And there's my matrix again, right?
Yeah.
Okay, so what I can do, what's the first thing we did? We did a row swap, right? So I'm going to go into math. Not math, what am I talking about? Matrix. Matrix math. And if you take a look at the bottom, you have your row operations. Here's our row swap. Here's our multiply a row, and here's our multiply add a row. Do we use these?
Hold on.
Someone say no, Mr. Williams, no.
What happened?
No.
Paying attention.
And I forget the notation here, so give me a second. Matrices. I wasn't planning on showing you with the calculator, but that was going to be nicer. Okay. So let's start with a row swap. You guys ready? I'm going to go up to row swap. Which matrix? Matrix A, right? So I'm going to go over to, there you are. I'm going to go over to matrix. I want matrix A, and I want to swap row, comma, row 1 with row,
Wait, where's comma at?
it's right above 7.
Right above 7. Oh.
Okay? So what I'm telling this computer to do is, for matrix A,
Until we quit.
swap row 1 and row 2. And when I push enter, it'll say, look at that.
Wait, mine didn't do that.
Mine did.
Hold on.
Don't say anything, be quiet. Don't say anything, be quiet.
I see it.
Wait, we go to math. Wait, we go to second matrix. Math. Row swap. Row swap. Hold on.
I
I'm
got
trying to
it.
figure this out.
Okay? Well, you know, I'll just go ahead and say it. Let me have your attention for a second. at the end, I'll show you the easiest way you can do it, and you have to do pretty much no math. Yes. Well, you might say yes, but this is a college prep course. So you still need to know how to do this. This might show up on your writing final.
No.
And it'll say, how do you do this part, how do you do that part?
No.
And if you don't know how to go through the process, then you're SOL. Sorry, out of luck.
Sorry, out of luck.
And you will be asking for some SOS, right? So, I'm trying to show you guys some of the easier things. This will take out the monotony of having to do it on paper, because there's my matrices right there. Okay? So let me just get through a few of these things so you can get the grasp of what's going on. What did we do next?
We multiplied row 1 by -4 and then added it to row 2.
Alright, so let's go over back to matrix. And we're going to go over to math. And it looks like we multiplied a row and then added it to another row.
Yeah.
That's times row plus.
And then
Okay? So here's the notation for times row. You're going to go value.
Hold on. Okay,
Wait, what?
continue.
So what value are we multiplying by?
oh, -4.
So we're going to type in a -4. -4, comma, oops, that's not what I wanted, comma, which matrix, so you might want to make a note of this. In this case, I want matrix A, and then I'm going to talk about which row to which row. So, comma, which row did we multiply by?
Row 1.
Row 1,
And then we added
and then we added it to row
2.
2. And then we close parentheses. So make sure you know that notation there. Value, matrix, row A, row B. Once you hit enter, it'll give you, oh, that's not right.
Yeah, see, that's what I.
That's what I got too. That's what I got.
That should be a 0 under there, shouldn't it?
Yeah. What is it?
Oh, no. Did you forget to add?
No, I didn't.
So it says value, matrix, row A, row B. Returns a matrix with row A of matrix B multiplied by a value and then added to row B and stored in row B.
Where the heck is this fucking comma? Seriously? Where's the comma?
So what ours did was by 4. It didn't multiply by 4.
It switched. Oh my goodness. Are you just a little confused
Yeah.
right now?
I don't know what it did.
It says like a rule.
Yeah, that's not right.
It says like they're pallets.
They use the same they use the same one from up there. Like, because the 4 and the 12 are not swapped.
Let me go up.
The 4 and the 12 are through the bottom and they're not swapped. The 4 and the 12 is a -20 are swapped. Right?
Well, like, yeah, well, they're supposed to be underneath, but they swapped them.
Yeah, I got swapped again. But they used the same ones that were on the first 8.
Yeah.
Oh, we did swap the second row, huh?
Yeah, they didn't swap the second row.
So you have to do that twice then. How would you do that twice?
Run it off.
All right, you know what? We'll come back to this when we have more time. Let me show you guys a shortcut. I don't want to do it today though.
Don't do it today then. Don't do it.
Then we're
Do it
just gonna suffer
tomorrow.
for our homework.
Yeah, you're gonna suffer. Let me just show you here. Let's go real quick. So this is what our A looks like right now. Let's see here. Let me clear this, and I just want to double check that that's what it looks like. Okay, so matrix A. Okay, so here's what our matrix A looks like right now. Here's what you're going to do.
Hold on, wait.
Simplest way, if you're just trying to get to a solution, because you can do this with any systems, like even when we're doing the two equations, two variables, same idea. Second matrix, over to math. And if you push up, right above those row operations, you're going to see REF and RREF. Guess what they stand for? REF stands for row echelon form.
And reduce row echelon.
And RREF stands for reduced row echelon form. So if I click on those, so let me go up to, I'm going to do REF first, okay? So if I do REF, and then I plug in, which matrix did I want? Matrix, I only have one. If I plug in matrix A, push enter, it's going to spit it out in row echelon form. Okay? No, because we messed it up with the row swaps. It didn't do the swaps correctly. Okay? Now,
Wait, did we not do those swaps correctly whenever we were doing?
no, because we have to tell it to swap. When we did the row swap, 1 with 2, it swapped row 1 with row 2, but it didn't swap row 2 with row 1.
Oh, what I'm saying is like, whenever we did by hand, because isn't it the same as when we did by hand?
Right, that's what I'm saying. So I got to figure out how the row swap works, okay? All right, let me show you something real quick also. Sometimes you're going to get these nasty bits. If there is a fractional equivalent, you can just go over to math, frac, and it's going to turn the answer into a fraction. And if there is, it's going to give it to you in fractional form, which is much nicer. Okay?
Yeah, like everything.
Yeah. Really. And I'm sure you can figure out how RREF works, right?
Yeah.
Same thing. That is it. Let me stop this.